Welcome, everyone, and thank you for joining us today. My name is Paul Donahue, and I will be your host. We ask that you please keep your device muted during the session, and if you have questions, please direct them to me via the chat function. We'll do our best to answer questions at the end and to follow up with any unanswered questions by email. As I think you all know, these tech talks have been designed to provide straightforward insights into radio frequency components. We talk about the different technologies involved and certainly the extra design and engineering value that is added by a custom manufacturer such as Quantic TRM. To begin today's session, I'm once again pleased to introduce Quantic TRM's Chief Technology Officer, Shaun Moore. The author of 2 U.S. patents and numerous white papers and technical articles on passive microwave technologies, Shaun has been with the Quantic TRM team since the late 90s, and his passion for the job and for solving problems has only increased over the years, especially when it comes to resolving our customers' design and engineering challenges. So welcome, Shaun. Can you share an overview of today's topic and your objectives for the session?
Yes, absolutely. Thank you, Paul. So today, what we're going to talk about really is Space 2024 or New Space. We'll go ahead and we'll talk about what that is. We'll then kind of dive into it and we'll talk about really some specifics relating to space flight mission requirements, what are required, what is not required, how we handle that, what sort of a risk that are associated with those testing and those sorts of environments. We'll go through some examples. Then we'll wrap it up with a summary and then have a discussion about some of Quantic TRM's differentiators.
Okay, so what exactly is this new space that you mentioned?
Sure. So new space is really kind of a spin on words here, but really it has to do with really mission profiles and what our customers are beginning to look for. And a good example of that is if you go back a few years and you look at our customers that are in what is known as the traditional space market. These are the geosynchronous, very large, very expensive satellites that are put up. And in those cases, they have one satellite that is covering an entire sector of the globe for whatever function that it is. So in those environments, those are very expensive satellites, and their desire is to make sure that they do not have a failure. So as a result, they test every parameter of every component for every environment that is being put on that satellite. So this is a very low risk approach, and I think that as the satellite industry was being developed, this made a lot of sense. The cost to launch satellites was extremely high. The cost to build them was extremely high, and putting a little extra money in there to make sure that it was going to operate over these very difficult situations and environments made a lot of sense. It does a few things, though, to the cost of the product, is that it adds a substantial amount of cost to even some very small, simple products, even the passive components that Quantic TRM supplies. It adds a significant amount of cost. It also adds a lot of lead time because these tests take sometimes months to run going through there. It is, however, a very low-risk approach. What the new space environment is what they are looking at us now is they are trying to decrease the amount of testing, increase basically reduce the cost of what they're supplying, as well as reducing time. So what's really driving this is that a lot of the new space requirements are going now into LEO orbits, where they're talking about now building constellations of satellites to support those sorts of parameters. In that environment, they need very many more parts. Some of these constellations are several hundred satellites, and they need to be able to build these rapidly to be able to go ahead and fulfill their mission. Now, in a LEO situation, since they need so many more parts, cost now becomes much more important to them because they're trying to get the cost of the entire system down, and since they're launching so many satellites, cost really becomes a big deal. What they are attempting to do here is to leverage the sort of experience that manufacturers like Quantic TRM have in supporting the traditional space market for a number of years, to be able to leverage those sorts of experiences for the new space market. We can then, once we have that heritage, we understand really what the risk items are in failing for those sort of space environment, and then being intelligent about deciding really what is something that should be tested for, or something else that we can just do by analysis.
Okay, well, that makes sense, I guess. And maybe could you explain a little bit more about what it is that you mean by mission requirements?
Sure. So mission requirements are really going through there and seeing exactly what this part is going to see. Back in the traditional geosynchronous orbit, things were always over spec, and a lot of things nothing was taken for granted. What we are now seeing here for this new space environment, especially since cost is something that really our customers are looking to reduce in a dramatic way many times, is that we're looking and they're trying to see really what is in the design that is truly at risk. And how much of this we don't necessarily have to go in there and test for on every single design modification. Some examples here really are, for example, if we were to go in there and look at thermal cycling. Thermal cycling is done on virtually on a lot of components to look at overall reliability of things like solder joints and interconnections. We have been doing this sort of technology now for over 50 years, so we understand really what makes a good solder joint and what makes a good assembly, that therefore we're not putting any stress or strain on those solder joints. So to go in there and do this testing yet again, many of the new space requirements are now waiving this requirement, kind of relying on the fact that a manufacturer like Quantic TRM really understands what the requirements are, and we're going to build that sort of quality into the product anyway. Things like vibration and shock also are things that very often, again, costly tests to run, but they're relying on our heritage of being able to successfully delivering these parts over the years. Other things that are extremely costly to run are things like thermal vac testing and multi-paction testing. Now, a good example of multi-paction is that if you take a look at the requirement, how much power that the part is, how much voltage that the part is actually going to see in its operation. Very often now with these lower Earth orbits, the power is less because the satellite is small and there's less power available on the satellite. As a result, the power level or voltage level going through many of our components are not going to exceed the threshold required for a multi-paction event to even occur. And in that case, there's no sense in testing for it if the system level it won't meet the initial criteria for have the event to happen in the first place. Also, some of the thermal vac testing that gets done. Again, if the power levels are lower, then therefore you're not necessarily quite so concerned about getting the overall thermal management, because that now becomes much more controlled, and we don't have to go in there and do any kind of special design modifications to make sure that we have good thermal transfer through the part, or multi-paction or other sort of corona critical pressure breakdown issues. So since the requirements are changing, and a lot of these environments that could cause a problem really may or may not exist, or if they do, these are all issues that we've addressed through our heritage, and therefore many people who are now building this new space requirement are asking us to go ahead and just kind of design with the intent of, but not necessarily requiring us to test to these sorts of environments.
So if I've heard you correctly, then the track record that the manufacturer has makes a big difference in all of this.
Yes, absolutely. Absolutely, Paul. And it's really critical that if you're going to start waiving requirements, making sure that the vendor that you're working with really understands what those requirements are and has good heritage in those sorts of environments to make sure that that waiving those testing is actually valid.
So as a custom manufacturer, as you mentioned, with over 50 years of heritage here, what else would you say about the differences within new space versus traditional space?
Sure. So kind of getting back to this here, I said in traditional space, they always wanted to have the objective evidence that all parameters were always going to be covered. New space is requiring delivery of parts being much faster, and they're also looking now for a much higher volume of components. What we're seeing here now for a lot of our traditional space components is that an entire flight set could be 2 or 3, 4 or 5 parts, whereas now the new space quantities are in the hundreds for parts that are actually going on to spacecraft. So there's a very large increase in volume as we're going forward into new space. We're also seeing, like I said, this careful consideration of risk analysis that's happening with our new space customers in order to expedite the delivery of components as well as reduce cost. So the whole idea here is trying to reduce cost without really compromising the overall quality of the component that they're receiving. And many of our new space customers are willing to take a little bit more risk by not actually validating with objective evidence on every last parameter. And that is really helping them with their cost savings as well as allowing us to deliver these components in a much quicker fashion.
So you talked about maybe a willingness to take a little bit more risk, and you talked about maybe multi-paction not being as likely a failure as in the past. But what about other failure modes, and what else would you say about the risk that is faced in today's new space?
Sure. So, what I will say about a lot of these parameters, especially like for multi-paction and critical pressure breakdown, these are extremely costly tests to run. What we're finding, especially now for our new space customers, is they are very much willing to look at our analysis. And of course, we have heritage on these analysis showing that we have accurately predicted when this problem will occur and when it won't occur. Therefore, there's a lot of good confidence there going forward. Very often, for things like multi-paction, for example, even if it's going to be marginal, since we have been designing components for spacecraft now for 25 years, we can certainly go in there and we can design out the potential for multi-paction by using things like interlocking dielectrics and controlling gap distances, so we don't have that resonant condition that will create a multi-pactor event. So things like that, a manufacturer like Quantic TRM is very familiar with mitigating these sorts of things, and we can go in there and we can add these sort of mitigations to the design, and then look at it by analysis that yes, we will not have a multi-factor problem without necessarily testing for it. Our customers are finding confidence in that approach, and because of that, they've been able to save substantial amounts of money and time. The beauty of these sorts of failure modes is that the failure modes are fairly well understood. And if you're intelligent about the design and layout up front, the testing becomes almost academic. And therefore, the new space customers are very much in support of that and willing to and very happy to take the cost savings.
Okay, well, it's good information as always. Shaun, would you like to summarize?
Sure. Basically, the new space is focused on performance. Traditional space is focused on absolute performance and reliability. They wanted to see objective evidence for virtually everything going forward. They are less interested in cost and the time to deliver. Now, I'm not saying that cost and delivery time is irrelevant. However, those are not the biggest priorities on their list. New space, on the other hand, is much more focused on quick turns, certainly cost. They want to have a higher volume of components. They require a higher volume of parts. And now, in order to get the benefits of a quick turn and a reduced cost, they have to accept some risk. In which case, then all of the testing parameters may not be validated through objective evidence. And what they are trying to do now is to rely on component manufacturers like Quantic TRM that has good space heritage to ensure that they will indeed end up with a good high quality product that will not fail, but at a lower cost and a quicker delivery.
Well, excellent. And I think that we have time to talk a little bit more about how TRM is different, Quantic TRM's differentiators when it comes to space. Maybe it's part of that heritage you mentioned.
It's a big part of of how it is. And really, what we like to do is we like to work with our customers to make sure that that the product that we're delivering and the data that we're delivering meets the end customer's needs. We do this through a careful selection of materials and design approaches. We have a great team of engineers on hand to design unique packaging, robust mechanical packaging. We also have a full environmental lab in-house where we can supply objective evidence for meeting all those needs. And I think the bottom line here is that Quantic TRM is a solution provider who also provides some hardware. We like to go in there and work with our customers to make sure that the full gamut of what they need is satisfied. And that goes back down to hardware as well as objective evidence showing that the part does indeed meet all of its requirements when it's required.
Well, excellent. And we do have a question. And it is that I've read that there is an increase in the lower Earth orbit or LEO demand, and also that there is a wider range of end users that have come into this space industry. Has that also contributed to the change in their demand for testing and their risk tolerance?
Absolutely. I think that the fact that now we have many new players who are moving into the LEO space orbit really has changed the landscape. We're not always dealing now with the same players as what we did with the traditional sort of satellite design. So therefore, they are taking a lot of their commercial approaches to getting a good quality at a lower cost. In addition to that, since the volume for the new space is so much higher, that really is really dictating the fact that we cannot have these sorts of environmental screenings that we used to have on piece parts going through the factory. For a lot of our geosynchronous traditional sort of space requirements, it would not be unusual for an individual component for an ESS screening to be in the environmental lab for over a month. That's just for one piece. You can't build a constellation of satellites with that many months of testing and validation and actually get the satellite up on time. So as the volume increases, certainly there are trades to be made with the way that we specify the testing and screening to make sure that the schedule gets met. So I think that a lot of the new space people are very much aware of that. And that is all part of their plan. In addition to all that, of course, they're very cost conscious, and it's sort of a thing where if they can maybe take a little bit of risk on the objective evidence and pull the schedule in as well as reduce the cost, it's a trade that they're willing to make.
Well, that makes sense. So I think that in summary, the bullets on your screen really say it all. And if you are a customer and you have additional questions, we would love to hear from you. The engineering hotline number is on your screen, 888-677-6877. There's no cost associated with these calls. If you're one of our sales field reps, then you know your calls are always welcome. And you can also communicate through the portal. So thank you all again for joining us. And as always, Shaun, thank you.
Yes, thank you.